cold. I'm freezing in here. Feet, hands, everything is cold. I need something to get me going, to get my brain ready to do this geometry. I just need to just relax a little bit and let the music get into my body and make it lovely for me. I just need to feel the buzz. Just need to get my blood flowing, you know. I am not sure what just happened there. I believe something got a hold of me. Mr. What do you say? Mr. Anderson. Anyway, special right triangles. These are right triangles that are special. There are two types, 45, 45, 90 and 30, 60, 90. There's relationships between the legs and the hypotenuse to understand. That's what this is. The legs and the hypotenuse have special relationships, and the first one we're going to talk about is the 45, 45, 90. It's the easiest one to remember. In a 45, 45, 90 triangle, the hypotenuse is square root of 2 times as long as each leg. So in other words, you can use this formula here. A leg times the square root of 2 is the hypotenuse. Okay, so here I have it summed up. If you know the length of one leg, you know the length of the other leg because they're the same. Notice that this says x and x. That means the legs are the same, or you use this ratio here. The legs are the same, and times the square root of 2 is the hypotenuse. And notice that it's times the square root of 2 is a hypotenuse. So if you know the leg, you know the other leg. If you know the hypotenuse, in this case, the length of the hypotenuse is square root of 2 times the length of a leg, which means that if you know the hypotenuse, divided by the square root of 2 to find the legs. In plain English, if they give you this side, the hypotenuse, divided by the square root of 2, and you'll know these. If you know the legs, you multiply them by the square root of 2, and it'll give you the hypotenuse. All right, let's take a look at that. All right, looking at these two examples here, or three examples. All right, find the length of the hypotenuse. I know this is a 45, 45, 90 because I know the 90. 45, so that means the other one has to be 45. Do y'all remember why? Because all angles of a triangle add up to be, yes, 180. I know you said it. And so if the leg, remember the hypotenuse is diagonally across from the right angle. So if the leg is 6, that means this leg is 6. They didn't ask for that. That means all I got to do to find the hypotenuse is 6 radical 2. Just multiply by the square root of 2. Yes, you can get a decimal, but you can keep it like that for right now. What about that second one right there? If I know that the square root of 2 is, 4 radical 2, and 4 radical 2 is the length of both sides, I automatically know that these have to be the same. Remember isosceles triangles? If those are the same, then these have to be the same. And if this is a right triangle, then those have to be 45 and 45. Anyway, so if I have the same leg here and I need to find the hypotenuse again, which is diagonally across from the right triangle, what I have to do is take that and multiply it by the square root of 2. Now, you may not be able to do that, but I tell you what, this can. So if I do 4 radical 2 times radical 2, what are you doing, Mr. Freeman? If I know the legs, all I got to do is multiply them by the square root of 2, and it'll tell me the hypotenuse. So I do 4 times the square root of 2, and I'm also going to say times the square root of 2. Hit enter, and I get 8. So what's the hypotenuse here? It's simply 8. I could teach you that. If you want to know, talk to me. I can show you how to do that without a calculator. But we have use of the calculator, and it'll do it for us. All right? Let's look at this one, which I didn't write all the way. The hypotenuse is 9 square root of 2. So they give us the hypotenuse, okay? And they want us to find x, or we need to find the legs, okay? So if we know the hypotenuse, according to the notes, we take the hypotenuse and we divide it by the square root of 2. Again, this can be done in your calculator, which equals 9. Now, sometimes it won't be a whole number. For example, if your hypotenuse was, not a whole number, it won't be something with the square root of 2. If your hypotenuse was 17 or something like that, you would divide it by the square root of 2, and let's see what happens in your calculator. I'm going to say 17 divided by the square root of 2. All right? And hit enter. Look what it does. It's what's called rationalizing the denominator. It will change that up for you like that. We don't need to know about it. That's a topic that we really can get into in Algebra 2. But if you'd like to know again, I'll show you what happened here. But I would prefer this whenever you do that. If we do it on a test or a quiz, I want you to show me this. All right? That's the 45, 45, 90. Review that. It's very simple. The legs are the same. The hypotenuse is square root of 2 times any of the leg. Or if you know the hypotenuse, you simply divide it by the square root of 2 and you can find the legs. Okay, so in this problem, 9 and 9 for the legs. Let's move on. Let's talk about the 30, 60, 90 triangle. This one is a little bit more complex. That's why we did the 45, 45, 90 first. There's several different things you need to remember. So what you need to make sure you're doing is knowing first which triangle am I dealing with, because they have two different types of relationships. All right? All right. The hypotenuse in this triangle is twice as long as the shorter leg. And the longer leg is square root of 3 times as long as the shorter leg. Okay. What you need to understand with all this up here, maybe you can go back and read this. Those who really understand it can go back and explain this to me. There's the hypotenuse, which is the longest leg or longest side of any triangle. You have two legs, right? Always you have two legs. Two legs and a hypotenuse. The shorter leg is always the leg opposite the 30 degrees. The longer leg is always the leg opposite the 60 degree. Okay? So never should the shorter leg and 30 degrees be on the same side. All right, they should be opposite. Same thing goes for the longer leg. All right, so here's how it works again. There's three sides to this triangle. The longest side is opposite of the 90-degree angle and is called the hypotenuse. The shortest leg or side is the side that's opposite or diagonally across from the 30-degree angle. The longest leg, not the longest side, but the longest leg of these two right here, hopefully y'all understand what I'm saying. This and this is the leg, this is the shorter one, this is the longer one, and the longer leg is opposite the 60-degree angle. So let me say that again, just so you can be clear. Three sides to this triangle. The longest is the hypotenuse. The hypotenuse is the longest side. The two shorter sides are called legs. Legs, the shortest leg is opposite the 30-degree angle, and the longest leg is opposite the 60-degree angle. Okay? So I'm going to be talking about longer leg, shorter leg, hypotenuse, so you'll know which one I'm talking about. Here's the summary right here. The leg opposite the 30 is the shorter. The leg opposite the 60 is the longer. If you know the hypotenuse, divide it by 2 to get the shorter leg. Okay, do you see the relationship here? If you know the shorter leg, you multiply it by 2. If you know the hypotenuse, you divide it by 2. You see? So the key here, and I tell everybody this, is always find the shorter leg. You see how each one of these got an X in it? Because each one of these have a relationship. Each one of these, I'm freezing cold, so I can't talk. Each one of these has a relationship with the shorter leg. So based on whatever they give you, always find the shorter leg first. So how do we find that? If you're given the hypotenuse first, divide it by 2. You'll get X, or the shorter leg. If you know the longer leg, the coefficient in front of the square root of 3 is the length of the shorter leg, or divide the longer leg by square root of 3 to get the shorter leg. Okay? So what that means is, if you know this one, divide it by 2 to get the shorter leg. If you know this one, it should be the coefficient in front of the square root of 3. If it has like 7 square root of 3, then you know the 7 is the shorter leg. But if it's some number, you divide it by the square root of 3 to get the shorter leg. Okay? Let's look at some examples of that. All right, or an example, I guess, not examples with an is. Okay, so this is kind of walking you through this whole concept. All right, so notice here, they want us to find X and Y. All right, look at this. Find X and Y, write your answers in simplest radical form. Okay, so X has to be my shorter leg. How do I know that? Because it's diagonally across the 30-degree angle here. Y has to be the hypotenuse because it's diagonally across the 90-degree angle. 8 here has to be the length of the longest leg because it's across from the 60-degree. So you see what I did there? I checked to see what I had and I labeled it or named it based on what I saw. All right? So what did I tell you? Find the value of X, which is the shorter leg. They're going to walk you through this. It says longer leg, which is 8, equals shorter leg times the square root of 3. All right? So instead of going through this, you can actually walk through that. I'm going to tell you that since I already know that the longer leg is 8, I have to divide it by the square root of 3. Okay? This equals X. How do I know that? This really equals X times, I guess if I did the math, I could show you that this is really times the square root of 3 to get that. So I divide by the square root of 3 to get the shorter leg. So put that in my calculator. I'm going to do 8. Let's do it in the fraction form. Divided by the square root of 3, and you hit enter, and you get this. 8 square root of 3 over 3. So really what that equals is 8 radical 3 over 3. That's supposed to be X. Sorry about that. And so that's what X equals. So we know what X is. Now, again, that should be an X. I'm sorry. Now, in order for us to find Y, all we have to do, remember, if we know X, all we have to do is multiply it by 2. 2 times X, or the shorter leg. Okay, so that's what I'm going to do. I know what X is now, and I didn't even erase it out of my calculator, so all you have to do is hit times, and it'll say answer times 2, and I get 16 radical 3 over 3. Don't worry about what it looks like because we're not worried about that yet. Y equals 16 square root of 3 over 3. All right, to summarize, the 30, 60, 90 triangle is the little bit more complicated triangle. All right, you could walk through this and it'll show you how to do it. I tried to help you out by giving you this stuff here. The key here is always finding the shorter leg, which is opposite of the 30-degree angle. How do you find it? Well, you need to be given one of these two, the hypotenuse or the longer leg. If you're given the hypotenuse, in order to find the shorter leg, you divide it by 2. On this particular problem here, they gave me the longer leg. So I needed to take the longer leg, divide the longer leg by the square root of 3 to get the shorter leg. And so that's what I did. I did in my work here, I did 8 divided by a radical 3, and I put that in the calculator. That's how it went from this to this. Now, where did this come from? Well, this turns out to be my shorter leg. If I need to know my hypotenuse, all I simply do is multiply my shorter leg by 2. What's the key? Know if you're dealing with 30, 60, 90 or 45, 45, 90. These are more simpler. The legs are the same, and you take one of them and multiply it by the square root of 2. Now notice there's a 2 there. Notice that there's a 2 here. This 2 is not in the radical, so this is 2 times x. This 2 over here is in the radical. It's the square root of 2. So yes, you need to remember these. You need to know the relationship with 30, 60, 90 is times 2 to the shorter leg. With 45, 45, 90, it is times the square root of 2 to the shorter leg. How do you remember this and how do you work all this stuff? By practice, by doing it, by trying it,